Welcome to final BSc Statistics students. In semester 5, we have two papers, paper 5 and paper 6. Paper 5 is Sampling Techniques and Design of Experiments. The title of the paper 5 is Sampling Techniques and Design of Experiments, in which Unit 1 consists of sampling theory, the principal steps in sample survey, etc., which are all fundamental definitions we learn in Unit 1. Unit 2 consists of simple random sampling and its techniques SRS, WR and WOR. Unit 3 consists of stratified random sampling and systematic sampling, the two techniques. Unit 4 analysis of variance, one-way classification and two-way classification. Unit 5 design of experiments, which consists of principles of experimental design, CRD, RBD and LSD, the techniques we learn in Unit 5. This is the syllabus of paper 5. Sampling techniques and design of experiments. Today we discuss Unit 1 sampling theory. In lesson 1, today we discuss introduction to sampling and some of the key definitions. The introduction to sampling mainly depends on need of sampling and two more definitions, population and sample. In this topic, introduction to sampling, we mainly concentrate on what is the need of sampling based on two particular definitions, population and sample. First of all, I define what is population and what is a sample. In a statistical investigation, we consider a population characteristic. The entire study is based on various aspects of population characteristics. A single characteristic or various population characteristics. For a group of individuals or things etc., in which the group of individuals is called a population. Total number of things, for example, some electrical fans produced by a company, usually we call some things an item or a commodity, which are called total number of electrical fans, which is called population, which is treated as population. What is the definition of sample? Sample is a simple definition. It is a finite subgroup of the population. It is a finite subgroup of the population. That is, for example, a group of individuals living in a particular locality, group of persons living in a particular locality. If you consider some group of persons, then that is a sample, and total group of persons is called a population. Similarly, in the consideration of production of electrical fans in a particular day, if you consider a population, then production that is manufacturing the electrical fans, manufactured electrical fans in a particular hour, it may be treated as a sample. Like, now you see what is the need of considering the sample. If the population is large and when the complete enumeration of the population is not practicable or possible, then we consider a finite subgroup. In such a case, that is, whenever the complete enumeration of the population is not practicable or is not possible, then we consider a finite subgroup or some part of the population, that is called sample. The sample is nothing but some part of the population. It is a finite subgroup of the population. When we consider this, if the population is large and also that the complete enumeration of the population is not practicable, is not possible, then we consider a sample. So, based on the sample information, we assess the characteristics of the population. What we have started in the introduction, we have various aspects of the population characteristics. Now, based on the sample information, what we have to do? We have to assess what would be the characteristics of the population. So, the population characteristics are going to be assessed by the information which is collected from the sample. Such process of assessing the population characteristics based on the sample information is known as sampling procedure. That is called sampling. Such kind of technique of assessing the population characteristic, such kind of procedure of estimating the population values based on the information of the sample is known as sampling. Example: if a company produces some electrical fans, then what we have to do? We have to test the lifetime under whatever the specific conditions, specific measurements which are taken by the company, specified by the company. For this, what we have to do is we have to test all the fans. We have to check test each and every electrical fan. That is called complete enumeration. We have to test each and every electrical fan. All the electrical fans produced by the company. Testing all the electrical fans produced by the company. That is called complete enumeration. But it is much expensive. Testing of all the fans produced by the company is much expensive and also time taking. Hence, in this case, we consider only some number of electrical fans at regular intervals of time. That's very, very important. That we learn in another particular technique, statistical technique. Now we only specify at regular intervals of time called samples. That is, we consider some electrical fan produced by 8 o'clock in the morning. 1 or 2 electrical fans, and the 2 electrical fans we consider 8 by 8:30. Another electrical fan is going to be considered by 9 o'clock. Like, for every 15 minutes or 30 minutes we consider one particular electrical fan produced by the company. That is called at regular intervals of time. Likewise, we have to constitute a sample and we test those particular electrical fans considered at regular intervals of time, which constitute a sample, and we test it, that is, we test the sample and we give the conclusion, that is, we assess what is the lifetime of the electrical fans. We assess what would be the lifetime of the electrical fan. So that is called, this procedure is called sampling. This procedure is called sampling. Now we see another example. If you want to know the efficiency of the students studying in a particular university, for example, university consists of 30,000 students or 40,000 students, then we cannot gather the information from each and every individual, from each and every student. So therefore, we consider some of the students from various colleges, 30 or 40 colleges. We select at random, and each and every college we select some 5 to 10 students that constitute as random sample, and based on the information provided by the students selected from the various colleges, that is samples, based on the information of the samples, we assess the efficiency, that is the population characteristic, that is efficiency of the efficiency of the students studying in the total, that is in the total number of students studying in the university. So such procedure is known as sampling, that we have to identify and get the efficiency, measure the efficiency of all the students of the university, but in the place of that we consider a part of the population, that is some number of students from various colleges, and we take the measurements regarding the efficiency. To know the efficiency, we take some of the measurements, and we go and assess, and at the based on the whatever the characteristics we have taken for the population, we go and consider, and we gather the information regarding the same population characteristic, the efficiency here. Regarding the efficiency of the students, we gather the information, we collect the measure, and we analyze this particular measure. Using this particular measurements or the measures, we assess the population characteristics, that is the efficiency of the total number of students studying in the university. And such kind of procedure is known as sampling. So this is another example of sampling. Now we see in some of the situations we use the sample instead of the population. We support the sampling is done in some special situations, in some special cases. We discuss one by one. Even if complete enumeration of the population is possible, that is, if the complete enumeration of the population is possible, it is not at all desirable. Even it is possible, that is, complete enumeration is possible, that is not at all desirable in some cases. We see the cases. Example, some company producing crackers. Some countries, a particular country producing nuclear weapons. Is it possible to test each and every nuclear weapon? Yes, it is possible, definitely. is it practicable, or it is meaningful? Is it meaningful to test each and every nuclear weapon? No, not exactly. Why? If you test all the nuclear weapons, there will not be any particular single nuclear weapon remains at the end to use. Therefore, it is not at all correct. Complete enumeration is not correct. Okay, similarly you consider crackers, explosive materials, some kind of chemicals, etc. If you want to test the chemical, whatever the amount of chemical was manufactured, produced, then obviously no chemical will be there to use. If you want to use the chemical, there will not be a single piece of chemical if you do complete enumeration. So therefore, it is not at all meaningful, it is not possible, it is not at all desirable. In which the items, that is in these cases, producing crackers, nuclear weapons, explosive materials, the complete enumeration, that is in which the items are destroyed, examining the 100% inspection, which means complete enumeration. 100% inspection means complete enumeration. In these examples, even if 100% inspection is possible and population is finite, 100% inspection is possible, but even if it is possible, even the complete enumeration is possible, that is 100% inspection is possible, it is not at all desirable, because of the items will be finished after inspection. If you want to inspect crackers, no, there will be no crackers. Similarly, nuclear weapons, there will be no particular weapon is available at the end of the testing. Similarly, explosive materials or chemicals, etc., whatever it is, if you want to test it, test the 100% inspection, that is if you want to test all the items, it is not possible, then in such a case it is not at all desirable, then only one option is sampling. In such a case, one and only option is sampling. That means we have to test some of the items, whether they are working or not, whether they are useful or not. Then in such a case we have to go for sampling. Sample number of items are only to be inspected. Sampling procedures are only desirable. Okay, this is the one particular case. We see the another particular case. In some cases, even if the population is finite and even the inspection is not destructive, it is not destructive. So the above case is destructive. In this we are discussing the inspection is not destructive, that is material is not explosives, crackers, weapons, chemicals, etc. 100%, in such a case 100% inspection, that is complete enumeration, may not be considered because of several problems like administrative and financial implications and time considerations, etc. For example, I will give you an example. A car manufacturing company produces 200 cars per day. In this case, testing of all 200 cars, it is possible. It is possible. It is not destructive. But testing of all 200 cars produced in a day may not be considered. It may not be feasible. Why? Because of the two particular considerations, the time and cost considerations. If you consider in terms of money and in terms of time, These two particular points of view, the testing is not at all feasible. It is not at all correct, because it takes much time to test, to produce 200 cars in a particular day. A company may manufacture 200 cars in a particular day, but to test all 200 cars, it will take 2-3 days time. For example, it takes 2-3 days time. Then it is meaningless because of time consideration. That much of time cannot be spent on testing the items, and also it involves a cost. It takes more cost to test the items, so therefore it is not at all feasible. By considering these two factors, time and cost, it is not feasible. Therefore, in such a case also 100% inspection is not at all feasible and practicable. In such a case also we have to go for the option sampling, and we have to go for sampling, and we have to do the sampling procedures, sampling techniques, right? So this is also one particular special case. Even though 100% inspection is possible, but it is not feasible. Practically, it is not at all desirable. It is not at all to be considered. So therefore, sampling is one and only one option in these special situations, special cases. So that is, if you conclude this, in all these cases, the concept of sampling is used to assess the population characteristics. So to assess the population characteristics, the sampling is one of the best option in these examples, in these cases. So sampling is quite often used in our day-to-day life. You need not go for sampling is used in some particular practical situations, but sampling is used in daily life. For example, if you want to purchase a rice bag, then we see some particular, to decide the quality of the rice, we see some particular quantity of rice, some handful of rice, and from the bag, and we decide whether it is good or not, qualitative or not, whether do you want to purchase it. If you want to purchase, whether to decide whether it is going to be purchased or not, it is based on sampling procedures. It is based on sampling procedure. In daily life we use the sampling techniques. So we take a handful of rice and from the bag, and then we decide whether to purchase it or not, right? So simply, likewise, sampling is most effective technique to draw valid conclusions in less time with more accuracy of results about the population characteristics. So therefore, sampling is one of the most useful technique in drawing valid conclusions in very less time and with more accuracy, by providing more accuracy, which means most efficient techniques in these type of cases, as well as in day-to-day life. We use sampling techniques. This is one of the most effective method of technique of drawing valid conclusions about the population characteristics in less time with more accurate results. Now we learn some of the key definitions which will be used in these techniques, sampling techniques. Population. First one, population. Already we have learned population is the group of individuals or things or items under a statistical investigation is called population, or it is also known as universe. Population can also be defined as collection of animate or inanimate things under the study. So we can also consider the another definition as collection of animate or inanimate things under the study, right? Example, if we want to study the national income, the total number of earning individuals in the country can be treated as, is considered as the population. To study the efficiency of the students, the total number of students studying in the university can be considered as the population. To study the various aspects of the population characteristics in the production of steel company, all the steel items produced in a company may be considered as population. Likewise, many number of examples we can give. If we want to know the national income, the total number of individuals is treated as population in the country. In the country, it is treated as population. If you want to know what is the living conditions, in a particular locality, in a particular place, then we have to consider a group of families. Total number of families living in a particular region, living in a particular locality is going to be considered as population. So the family may be considered as a population, total number of families, total number of individuals may be treated as population, total number of students studying in university may be treated as a population, total number of items produced in a company may be treated as a population, number of electrical fans produced in a particular day, number of cars produced in a day. Likewise, we can define the population in a wide sense. It depends on a statistical investigation. Now we see the definition of sample. A finite subset of population is called a sample. That is, some selected individuals or things from the population constitute a sample. It may be individuals or it may be things. It may be things or it may be individuals is considered as a sample. Likewise, the population, whatever the units are considered in the population, same units are also to be considered in the sample. But sample is a simple definition of finite subset of the population. It is some particular part of the population we consider as a sample. Examples. To conduct a study on national income, selected group of individuals from various income groups, low income group, middle income group, high income group, etc., from various regions of the country constitute a sample. Some group of individuals from various income groups. That's what we have considered the samples in this example. Another example, to study the growth in research and development in the country, a group of students taken from selected universities, which may be constitute a sample, which may be treated as a sample, to study the various aspects of the product of a particular company, some selected number of items produced may be considered treated as a sample. Some number of selected items at regular intervals of time. By 8 o'clock we have considered 3 items, 9 o'clock we have considered 5 items, etc. It constitutes a sample. Like this is the definition of sample. Sample is a part of population or finite subset of population. It is known as sample. The third definition, parameter. It relates with the population. Parameter is always relates with population. Population constants are called parameters. The definition. Population constants are called parameters. What are the constants of population usually? Means, variances, standard deviations, proportions, etc., which are refers of the population, is known as population constants, is known as parameters. We'll see the examples. The average per capita income of the country, that is a fixed value. It is a one particular fixed value at a particular time period, at a particular point of time. So it is a parameter. Average marks in a subject, that is, if you want to know the efficiency, we calculate average marks of a particular university, of the students studying in a particular university. Average marks in a particular subject of the students in a particular university, it is called parameter. Similarly, average annual sales of a product in a particular company may be considered as parameter. So these are some of the particular parameters. Similarly, if you consider, if you want to know the variation, then variation in the data, then we consider some particular standard deviation. The standard deviation of marks in a particular subject of a particular group means a population, of a particular population, that is in a particular university, then it is nothing but parameter. The standard deviation of per capita income of the country, it is also treated as parameter. Now come to the definition of statistic. Statistic is a function of sample observations. It is a definition of statistic is a definition of function of sample observations. So various measures, the means, variances, standard deviations of the sample, which are called as statistics. It is not a subject statistics, it is a definition statistics. It is a definition. Examples. The average annual income of a selected low income group people in a particular city is considered as statistic, is may be treated as statistic. Similarly, average marks in statistics of a selected college from the university. Here I should specify what is population parameter, what is the statistic. The parameter is the average marks of university. Simply I am specifying. The statistic is average marks of a particular college. Of course, it is related with the subject. Average marks of subjects in a particular, in statistics, in mathematics, of a selected college is statistic. Of university, it is parameter. Hope you understand. Similarly, the average annual income of the country is parameter. Average annual income of a particular group, maybe a low income group people or middle income or high income in a particular locality, in a city, it is nothing but statistic. Similarly, standard deviation of production of paddy in a mandal of a district. Why we are specifying both? Mandal represents sample, district represents population. So therefore, statistic here in this case is standard deviation of the production of paddy produced in a mandal is statistic. If you refer district is a population. That is the standard deviation of the production of paddy in the district, it is parameter. If you consider in the district as statistic, in the state Andhra Pradesh, for example, it is treated as population, parameter of the population. So it is a comparison. When we consider a group of a subgroup of the population, the measures related to the subgroup are nothing but statistics. The measures related to the population, actually we should not specify like that. The measures related to the population are to be considered as parameters, which are called constants. Population constants are called parameters, and statistic is nothing but a function of sample observations. It is a function. It is a function of sample observations. So these are two another definitions, parameter and statistic. I repeat again, parameter relates to population, statistic relates to sample. Another definition, sampling unit, the smallest possible division of the population. Remember, sampling unit, it is a definition taken from the population. The smallest possible division of the population to constitute a sample. To constitute a sample is called a sampling unit. The smallest possible division. For example, in agricultural experiment, if you consider agricultural experiment, if you consider a particular field, some particular plot of the field, I repeat, some particular plot of the field, then that particular plot is called smallest division. It's called sampling unit. Similarly, I have given examples. A sample survey relates to some human beings, persons, then the individual person is treated as sampling units. That is the smallest possible division. In medical experiment, a patient is considered, maybe treated as a sampling unit. In agricultural field, just now explained, a plot is treated as a sampling unit. These are the examples of sampling unit. So sampling unit is nothing but a smallest division of the population. So population consists of, for example, 100 units. Each and every unit is sampling unit. You have to remember in that fashion. Each and every unit of the population is nothing but sampling unit. Because we always consider a smallest possible division only. That is, after doing this, after sampling units are decided, the population is going to be formed. It is going to be constructed, considered. Next definition, sampling distribution. Simply to specify the distribution of statistic. The distribution of statistic is known as sampling distribution. If I say, now you see in detail, the number of all possible samples of size n drawn from a population of size capital N is known is NCN, capital NC, small n. For example, if there are 5 units, capital N, of the population, if you want to draw 2 units in the sample, the possible number of samples are 5C2. 5C2. Right? That is the formula. So 5C2 is 5 into 4 divided by 2, that is 2 into 1. So it is 10. Right? So there are 10 number of possible samples are there. That you please go and write it, and so that you can understand. I'll explain in another technique. A statistic T, for example, it is computed. For example, a statistic T is computed, maybe mean or maybe variance, maybe standard deviation, etc. Is computed for each and every sample. Whatever the possible sample, for each and every sample, if you calculate mean or variance, that is called statistic, which will vary from sample to sample. If you calculate the statistic, it may be varied from sample to sample. If you calculate all the statistics, for example, the T, it is going to be calculated for all the samples. If you calculate the statistic, then the aggregate values, the aggregate of the various values of the statistic under consideration so obtained may be grouped into a frequency distribution. It is known as sampling distribution. Sampling distribution. So that is, sampling distribution is nothing but distribution of a statistic. What is meant by distribution? Distribution is nothing but simple arrangement. What arrangement of what? It is an arrangement of statistics computed for each and every sample. That's all. Statistics computed for each and every sample. Possible sample, still to specify clearly, possible samples. The aggregate values of various values of the statistic under consideration is obtained. If it is grouped in a frequency distribution, that is the distribution of the aggregate values, the distribution of the statistics computed from all the possible samples, is known as sampling distribution of statistic. Do you understand the definition? It is a distribution. Sampling distribution is nothing but frequency distribution or grouped frequency distribution, or simply distribution. It is obtained for each and every statistic, all the statistical values, that is statistics, which is going to be obtained for each and every sample, for all possible samples, is known as sampling distribution of statistic. We see the example. Let x1, x2 and so on xn be a sample drawn from a population with mean mu and variance sigma squared. If the statistic is computed as sample mean x bar, then it satisfies, that is, then it follows a normal distribution with mean mu and variance sigma square by n. Mean mu and variance sigma square by n, which are called parameters. Mu and sigma are called parameters here. Mu and sigma square are parameters. X bar is statistic because it is computed for sample values x1, x2 and so on xn. Right? So if you consider all possible k samples, for example, there are k samples are possible for n1, n2 and so on nk. For the sample sizes n1, n2, nk. If you calculate what we have discussed so far, whatever the possible samples, for all possible samples, if you calculate first of all statistics, that is statistic x bar, sample mean, we have considered in this example. Sample means we have to calculate for all possible samples. For first possible sample n1, the sample mean is x bar 1. For n2, sample mean is x bar 2. For nk, the sample size, the sample mean is x bar k. If you formulate a distribution means arrangement, that is frequency distribution. If you arrange all these possible, for all possible samples, all statistics, if you arrange in a particular table, which gives the sampling distribution. Now you see that the sampling distribution of the statistic sample mean can be represented. It can be represented in this way, in this table, that is called sampling distribution. What is the table? Samples 1, 2, 3, 1, 2 and so on k, sizes n1, n2 and so on nk, means. For n1 mean is first sample, for first sample mean is x bar 1, second sample of size n2 mean is x bar 2, for kth sample of size nk the mean is x bar k. This distribution is known as sampling distribution. The distribution, sampling distribution is nothing but arrangement of all statistics for all possible samples. For all possible samples, for example here k possible samples, is nothing but sampling distribution. We see one another definition, standard error, which is one of the very important definition. Standard error. What is meant by standard error? It is the standard deviation of the sampling distribution of a statistic. Standard deviation of the sampling distribution of a statistic is known as standard error. So standard error is nothing but standard deviation. For what? For sampling distribution of a statistic. Simply, if you want to specify, standard deviation of statistic is known as standard error. The statistic must belongs to the sampling distribution. That's all. So that is the reason why the definition is the standard deviation of sampling distribution of a statistic is known as standard error. It is denoted by S.E. SE. The standard error of some of the statistics which are specified here, you please observe. I will tell you the simple notation to understand those standard errors. N is sample size. Let me clarify some notation here. Let me clarify the notation. N sample size, small n. Sigma square, population variance. Sigma, population standard deviation. Capital P, population proportion. Rho, the correlation coefficient. There are some notation. So if you consider here statistic, I am writing here statistic and standard error. For 4 statistics, I have considered standard error. I am furnishing here standard error. Sample mean x bar, if it is the statistic. If the statistic is sample mean x bar, the standard error is sigma by root n. Sample standard deviation, yes, standard error is sigma by root 2n. Sample variance s square, standard error is sigma square into root 2 by n. If statistic is sample proportion small p, then standard error is square root of pq by n. Square root of pq by n. So this is the definition of standard error, and these are the some of the standard error of statistics. Hope these are the definitions, some of the key definitions which we use in the sampling techniques. Thank you.